Okay, two charged parallel plates are separated 5 centimeter. The potential difference between the plates is 2 kilovolt. Alright, calculate the electric field strength between the plates. Okay, let's do the question A first. You want to find the electric field strength between the plate. Alright, okay, I have two parallel plates. Remember, this is about parallel plates. Two parallel plates. It's not a point charge. Okay, let me draw up the diagram first. Two parallel plates. Two parallel plates like this. Okay, so one is positive, one is negative, because got potential difference between them. Yeah, so separated by okay, how far between? Separated by the distance between them is 5 centimeter. This centimeter need to change to meter. Yeah, and then potential difference between them. Potential difference. Okay, I can say this is the D. This is the D. Potential difference means delta V lah. Delta V, yeah. Potential difference. Difference in potential between the two plates. Okay, so this is the delta V. Okay, so delta V equal to 2 kilovolt. 2 kilovolt. Yeah, kilo need to change to volt lah. Kilovolt need to change to volt, SI unit. So find the electric field strength between the plate. Okay, I can say electric field strength is always from positive plate to negative plate. Yeah. Okay, let me draw it out. It's always from negative plate, positive plate to negative plate. Yeah, electric field direction. This electric field. So I want to find the electric field strength in between the two plates. Yeah. So how? What is the formula? Which formula do we use? Is it we use, electric field strength is KQ over R square? Is it? Yeah? Wrong. This is for point charge. This is for point charge. Not this one. Not this one. Okay, so for parallel plate is this formula, E equal to delta V over D. This is for parallel plates. This is for parallel plates. Yeah, two parallel plates. This one, yeah, not this one. Understand? Not. So if you still remember this one, you see, parallel plate or capacitor, uniform electric field, we use delta V over D, not the KQ over R square. KQ over R square is for the point charge. It's non-uniform electric field. KQ R square. So not this one. Use this one. Okay. So now so delta V is 2 kilovolt. Change to SI unit. Kilo is exponent 3. Yeah. Kilo exponent 3. Okay. And then volt, in volt. D is 5 centimeters, change to meter. Change to meter, so centi is exponent negative 2. Or you divide by 100. Divide by 100. Or exponent negative 2. Yeah? Change to meter. So you get the answer already. Understand? Remember this one? Remember this one? Okay, so 2 exponent 3 divided by 5 exponent negative 2. 5 exponent negative 2. Okay, so I got 40,000. 40,000. So 4 exponent 40,000. 4 exponent 4. 4 exponent 4. Yeah, 4 exponent 4. Okay. 4 exponent 4 Newton per coulomb. Okay, Newton per coulomb. That's it. I can write Newton per coulomb, or I maintain the unit. Better if this question you maintain as volt per meter lah. Normally Newton per coulomb is if you using this formula. This one you use the point charge one, you use Newton per coulomb. the parallel plate one, you mostly use volt per meter. Okay, because you got from here, you see, volt per meter, volt per meter. So you try to maintain the unit lah, yeah, volt per meter lah. Okay, understand? Point charge one, you use Newton per coulomb because it involves this, you know, the formula E equal to Fe over Q naught. So because of this, force is Newton and charge is Coulomb. That's why you end up become Newton per Coulomb. Understand? That's why you end up become Newton per Coulomb. Force per unit charge, Newton per Coulomb. If point charge, you normally use Newton per Coulomb. For parallel plate, normally you use volt per meter lah. But if you want to use this one, Newton per Coulomb also can. Never mind, yeah, it's usable also, yeah, no problem. Okay, it's the same. Unit Newton per Coulomb and volt per meter is the same. So electric field strength has 2 units. Yeah, has 2 units. Both also can use. Yeah, both also can use. Okay, so the answer is correct. The answer for exponent 4 is correct. Answer is correct. So right now, what is now B? Question B, he says an electron is placed between the plates. Okay, now you have electron in between the plate. Okay, let's draw an electron there. Okay, I have electron there. Yeah, electron, negative charge. Yeah, electron is a negative charge. Electron is a negative charge in between the plate. Yeah, I have electron there now. Electron. Okay. Okay, wait. This is an electron charge. Okay, this electron, of course, it will be attracted to the positive plate lah. Yeah, it will be attracted to positive plate. And draw the draw the direction of. Okay. It will be attracted to positive plate lah. This is the electrostatic force lah. For negative test charge, normally the force and electric field are opposite direction. I did explain about this before, right? In my lecture video. For negative test charge, the force and electric field normally is always opposite direction. Electric field to the right, force to the left. You see that? Electric field to the right, force to the left. If this test charge is a positive test charge, then the force and electric field same direction, both going to the right. That's the difference, yeah. Electron, negative charge, always attracted to positive plate. That's why the force is to the left, opposite to the electric field to the right. Yeah, force and electric field opposite. Opposite because of negative test charge. Okay, back to business. Now he asking about the force. Yeah, he asking about the force. Is it force on the electron? Is it increase, remain the same, or decrease? He asked about the changes of this force, electrostatic force. Is it increase, constant, or decrease? If he said the separation distance between the plate is decreased, he give the changes is the D decrease. He said this D decrease. What will happen to the force? And explain your answer. You must give evidence. Evidence of using formula. Understand? So how to do this question? So D, okay, delta V is doesn't say any changes about delta V. So that means we assume delta V is constant. Okay, only the D decrease. So if D decrease, something will happen to the electric field. And when something happens to the electric field, something will happen to the electric force also. Okay. So look back. Okay, just now this is for question A. Now let's do question B. Question B. So okay, what will happen? What will happen to the when D decrease? Okay, when D decrease, so what will happen? So look at this formula. E equal to delta V over D. Okay, delta V over D. Okay, so when D decrease, E will increase. And delta V is still constant. Okay. So okay, let me write it down. Yeah, when D decrease, I can say the E will increase. E will increase. Okay, because E and D is inversely proportional. Inversely proportional. So when D decrease, E increase. So what will happen next to the force? We use the formula F equal to QE. We use the formula F equal to QE. This is just now. This is the first formula. Now the second formula is F E equal to Q naught E. From this F equal to Q naught E is actually come from this formula. Yeah, this Q multiplied to the top, so we have Q naught E lah. Yeah, force is the test charge multiplied electric field strength. So what will happen if E increase? If E increase, the force will increase. The force will increase because it's proportional. So we can say, so the thing is, the electrostatic force will increase. Will increase. Sorry, will increase when, I can say, when D decreases. When D decreases. So that's the answer. That's the answer. Okay, the force will increase. The electrostatic force on the electron will increase when the D separation between the two plates decrease. So what's my explanation? Where is my explanation? Explain your answer. My explanation is my explanation is this. This is my explanation. Explanation using formula. So remember, your explanation always must have formula. Always must have formula to show a proof, evidence. Understand? Formula is evidence. Don't ever just storytelling. Storytelling has no evidence. Okay? Storytelling has no evidence. We always talk with evidence. What is our evidence? What is our explanation? Our evidence is using formula. The formula is the explanation. Yeah, based on this formula, when D decrease, the E increase. And then based on this formula, when the E increase, force increase. So that's all. Okay? So when D decrease, the force increase. Okay? So that's our explanation. Okay, so that's all for this question. Yeah, I hope you understand, and goodbye.